Hey guys, Mr. Myers here. Wanted to give you a quick tutorial on how to name ionic compounds that happen to have a transition metal for the metal. Not terribly different from what we've done, but in this case, as I mentioned previously, some metals can have multiple charges possible. So multiple charges. And these charges, if you go on to IB chemistry, for example, or down the road in college, you might hear them referenced or referred to as oxidation states. So these metals that have multiple charges primarily are transition metals. There's a reason why we don't discuss valence electrons with the transition metals, and part of it, they have a lot more, it's a lot more complex than what we've discussed. And as such, they can lose different numbers of electrons in order to become stable. So we're gonna not worry about the explanation part, but if we come across a compound, we have to figure out, do we name it a certain way specially or not? So let's take, for example, this formula, FeO. How would we name that? If you said iron oxide, you would be correct. Now, how would we name this compound? Hopefully you see where the confusion hits in, because this too would be iron oxide. And so what we have is a situation where iron can pair up with oxygen a couple different ways, because iron has a couple different charges that are possible. And so if we call it iron oxide, that is no longer sufficient. We have to have a new method to fix this scenario. So what we do in the case where a metal can have multiple charges is we use a Roman numeral to indicate what the charge or oxidation state may be. Okay. A lot of folks seem to forget what the Roman numerals are, so we'll label them here. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I can tell you with certainty and confidence that at most, I think we're going to see 1, 2, 3, 4, 5, maybe 6, maybe 7, but I don't really see it. So at least like 1 through 6 for sure. So what the Roman numeral does is it tells us the value of the charge. So if you have a Roman numeral of 1, that equates to a +1 charge. If you have a Roman numeral of 2, that's a +2, and a Roman numeral of 3 would be a +3 charge. All right, so back up to our example above. How do we figure out what the charge is in order to do this Roman numeral thing? Well, when we're doing this, because the metal can have different charges available or possible, always look to the anion. Okay, the anion charge is always definite, right? So oxygen, what's the charge of oxygen as an ion? Hopefully you said -2. Well, if this compound here is neutral and oxygen is -2, then what does iron have to be to balance it? Right, it has to be a +2. And so the way we would name the substance is iron 2 oxide. We put the Roman numeral right between the cation and the anion, because the number here refers to what comes right before it. So iron 2 is referring to iron +2. Okay, I'll scroll down a bit for a moment. With this iron Fe, or the Fe2O3, The oxygen here, oxygen's always a -2. And because there are 3 of them, well, total, that's a -6 charge that's there for the compound. Well, what balances a -6? +6. And there are 2 iron. How many times does 2 go into 6? Hopefully you said 3. So that means that iron here is a +3 charge. So the name up here, iron 3. There is another way to figure out the charge of iron. So if you have Fe2O3, well, we could reverse crisscross. All right, and what that gets us is an iron +3 and an oxygen -2. And we say, oh yeah, hey, oxygen's a -2, that's the definite charge, so this is correct. And then naming would be, again, iron 3 oxide. All right, but you won't always be given 2 substances like the 2 iron oxides to figure out. You'll be given a compound, for example, let's say NiBr2, and we're like, oh, hey, what is that? And you're like, oh, Ni, that's nickel, and bromine or bromide. Okay, but is that the complete name? It's a transition metal, so we might think there's a Roman numeral. And in fact, there is a Roman numeral. If you figured out 2, you're right. But what I want to do is give you a shortcut, if you will, or rules to follow as far as an exception. Okay, so these exceptions are going to be metals on the periodic table with only 1 charge, which means that they do not get a Roman numeral. So the question we would ask ourselves is this metal one of our exceptions? If it is, then it only has 1 charge, and so there's no Roman numeral. However, if it is not one of our exceptions, then multiple charges are possible, and we have to solve, like we did above, for the corresponding charge. So what are these exceptions? Well, if you are a group 1, 2, or 3 metal, you have 1 charge, right? A group 1 is a +1, group 2 is +3, and group 2 is +2, and group 3 is +3. Okay, those are the only charges for those respective groups. Additionally, cadmium only has a +2 charge. Zinc is only a +2 charge. Silver is only a +1 charge. And lastly, scandium will treat as having a +3 charge. So these here are our exceptions. So back to the one up here, nickel. Nickel is not one of these exceptions. It is in the middle of the transition metals and not one of these exceptions, like I said, so it gets a Roman numeral. What about, let's see here, this one. Okay, this compound right here. For the pause. So SN is tin. PO4, phosphate. And our question is tin one of our exceptions? So we look on a periodic table. Okay. And tin is right here. Tin is in group 4. Well, group 4 is not one of our exceptions, and it's not one of the other 4 there. So therefore, it gets a Roman numeral because it can have more than 1 charge. So one way we can do this is look at the anion. Phosphate is a -3. There's 4 of them. So -12 means +12 balances. So tin has to be a +4. The other way we could have done it is to say, well, let's crisscross, and that matches up with the charges we predict. So tin, IV for the Roman numeral, it's tin 4. All right, I hope that helps. When if you get stuck, always return to the exceptions and ask, is it an exception? What's nice too, real quick, is if we go back to this example, if I gave you the name nickel 2 bromide, what that would tell us is that nickel is a +2, and then bromide we'd have to figure out as being a -1, and then we could crisscross to get the correct formula. So you will have to go back and forth. You have to go from formula to name and name back to formula. If I gave you a different name like silver carbonate, we'd have to ask, well, silver is one of our exceptions, and you'd have it in your notes here that it's a +1 charge. And carbonate, you could look up on your polyatomic ion list to find that it's a -2 charge. So when we do the crisscross, we would get this for the formula. I hope that helps. Have a good one.